Okay. Come see me. I'm in 1410. Hersman's in 1400. Between those two rooms, you should find somebody. I was there. Now, do I really have to write number 3? Yes. 7:15. I tried for earlier, but the dog is kind of keep me from that. Yes. Yes. Math team, we're having an introduction to math team tonight. If you want to find out more about it, right here. I think we'll go in this room after school. If you can't make it tonight, we'll have another meeting next week. Okay, what about the 3 conditions for continuity? I shouldn't have to write them. Do I have to write them? Now, I told the other class, if everybody gets that problem right, I'll give you suckers. In this section. I won't even pit you against the other section. Just this one. 75% of you will get it right.
Today?
No, you have to get it right tomorrow on your test. You know it's a test question, right? So knowing you have a test question, I think I would make sure I know how to do that. Definition of continuity. Okay. Now, this is at a point C. What is the first condition? Good. Not f of x. Now, in math, we're very precise. Brian? We're very precise in math. So you cannot just change things and say, well, f of x must exist. That's not the same thing. Okay? So it's got to be exactly the same. Normally, I say, okay, there are different ways you can do things. B. The limit as x approaches c of f of x must exist. So everybody here should get at least 3 points. Way more than that, but anyway. Can you draw a function where the function, does the limit exist here at this c value? Yes. Okay, so if you're traveling down the road this way and somebody's coming that way, eventually you will meet. At infinity, you will meet. And you will meet at L. That's all the limit is what you're getting close to. By the way, do I care what happens at C? No. Okay? So here's f of c. I'm also going to define my f of c here. But do I have a continuous function? No. So the third condition is, what do you have to do with this?
Limit is
You have to fill in that hole. They got to be equal. Does that make sense? Ann? For a limit to exist, the function must approach the same value from both sides. The point does not have to exist. So in this situation, the point exists, but there's a jump there, but that's not my formal definition. I'm not approaching the same value from both sides, therefore the limit does not exist. Okay? So the third thing here is A and B have to be equal. The limit as x approaches c of f of x must equal f of c. And how do you know if a limit exists? And I didn't have time to grab that question from last year. The limit from the left as x approaches c from the left of f of x has to equal the limit from the right. And if you think about real life, we run into this all the time. We don't write it with limits, but you do it. I'm going to meet you at the mall at such and such a place. This way. Now, do I have to check from both sides all the time? No, because if I have polynomials, rational functions, I'll call them rats, root functions, trig functions, exponentials, logs, all of those. Am I missing one?
Yeah.
Absolute value. are always continuous where the function's defined. So if there's a hole in the graph, like if you have a rational function, if I have f of x is equal to 1 over x, that is continuous everywhere where the function is defined. Where is it not defined? Because f of 0 does not exist. So when I'm looking at showing if a function is continuous or not, okay, guys, I would first start with A. Does every point in my domain exist? And if it doesn't, that's my first problem. And so I just say that value doesn't exist. That's it. Don't make it hard. You don't have to go through all three things. You can if you want, but you don't have to. Now, if the value of the function exists, like over here on my jump right here, it does exist, but then I go to the next one. Does the limit exist? In this case, the limit does not exist because the limit from the left doesn't equal the limit from the right. And if the limit exists, like it does up here in my very top case, this one right here, then the limit exists, the function exists, but it's still not continuous because this little red dot is not in the right place. And it happens, by the way, in the real world. Matter of fact, they just did that at Hastings. Did you see that they floated the bridge down the river? The bridge in Hastings has been out. They've been working on it. They rebuilt the bridge, and they floated it down the river on a barge, and they're hoisting it into place. They're literally taking the bridge and putting it in the right place. You just pray the engineers are right, that's all. Perfect example of defining a function so it's continuous. Okay, so now, if we go down to the next problem, do you have questions on number 4? It says, and some of it, you guys, is just the directions. I know in previous classes you've had a lot of problems that you solve and stuff, but there weren't any fancy directions. Now we're going to apply everything you've learned. Determine whether the function is continuous at -3, and then say why it is discontinuous, or if it's continuous, why it's continuous, using one of these 3 things in my definition of continuity. So I always check the first one. Oops. So the very first one is, here's my g of x. Do I need to go over this? This is a yes or no question. Yes. Okay, because I did another class. Now, how are you going to study for the test? You're going to cover up your answers. Can you do the problems again? Because I don't think you'll memorize them. Some of you are very good memorizers and might. Okay. You know that top function is a polynomial. It's actually a rational function. It's continuous everywhere except when the denominator is 0. What happens at -3? The denominator is 0. Actually, you get 0 over 0. All right? I don't want to write g of -3 because that's not true. Okay. First definition of continuity. Does g of -3 exist? And if so, what is it? The limit, it does exist because this is what they call the extended function. We just defined it. The same as that bridge in Hastings. Without the bridge there, it looks like this. There's a hole there. But now they're going to fix it, and they're going to say it's 7. But does it fit? Well, what do you have to check next? You have to check the limit as x approaches. Now, I don't have to check from both sides because it's a rational function. And I know the limit from the left will equal the limit from the right. Okay, can we factor that? Now, we know x plus 3 because we got 0 over 0. We know we had to have an x plus 3 in there. And this is what, 2x? Well, I got to get a -3, so it's got to be -1. It's easy to make a factoring mistake. Okay, as long as we're not at -3, which we're not, we're just getting close, then I can reduce this. Now, you guys got to be careful with your canceling. You just cancel things out. It's x plus 3 goes into x plus 3 one time. X plus 3 goes into x plus 3 one time. There's a 1 there. It's not a blank. Some of you like to put in blanks. So this function really looks like this. And at -3, there's a hole. Now, use your graphing calculator. No, you don't get it on the test, but you're still in learning mode. So go ahead and look at that picture. That's just a line. And at -3, there's going to be a hole. Well, what is the line getting? What will be the value of the line to make this work? It's 2 times what? Negative 3. This is the hard part, right? Minus 1, which is negative 7. So the limit is negative 7. The value of the function is positive 7. Is this going to work? No, because you say the limit as x approaches negative 3 of g of x does not equal g of negative 3. But somewhere you had better say that g of negative 3 is 7 and that the limit is negative 7. Not enough. And I know you're used to Marzano, it was just the final answer. You have to justify your responses. You have to say everything I've written up there. I know you've gotten by without doing that, but no more. And when you go to college, it's going to be even worse. All of this. I have to find that limit.
You don't have to like write anything out.
I wrote it out right here. The limit didn't equal the value of the function. And in fact, if you go and look at last year's exam, I don't remember which problem, but it was a problem just like that, on the free response.
Okay, instead of functions, you said negative 3 because the limit as x approaches negative 3, g of x should be negative 7 and it's 7.
Yeah, that's the same thing. He's just a little bit better verbally than me. Okay. Now the next part I think is what you find really hard, right? Did we do the first one? Yeah. Do I need to do it again? No. Okay, I always look to see if the function exists. Yeah, we'll do C. Whoops. Not with a highlighter, we won't. B is continuous because that's a rational function. We don't care about the numerator. Irrelevant. Okay, this is a rational function. It's made up of 2 polynomials. And remember, I said rational functions were continuous everywhere because there's a theorem, except when the denominator equals 0. So this is y equals x squared plus 4. Now I want you to think of this graphically. If you're having problems. Some of you are thinking about it algebraically, but if you look at it graphically, it becomes far easier to figure out what's happening here. X squared plus 4 is a parabola shifted up 4. Is it ever 0? So guess what? This is continuous everywhere. The denominator is never 0. Some of you try to factor it. That means it would have to have crossed the x-axis. Okay, you guys? Yeah, but math? Oh, okay. Is it related to this one or a different one? We are in B. Okay, so you're okay? It's continuous everywhere. Because all rational functions are continuous everywhere. There's a theorem. I love theorems. I can just invoke them. Anyway, except we have to worry about that. But it's not 0. If it's x squared minus 4, then we would have to exclude 2 and negative 2. But it's continuous everywhere. Let's look at C. And all I do, is I start with the very first condition. Where is the problem with this guy? Absolute value is continuous everywhere. X is continuous everywhere. But there's a problem. Okay, because what is h of 0? It's 0 over 0. So it does not exist. I'm done. You remember what this one looks like? Yeah, horizontal lines, yeah. Yes, we did. Okay, so they're horizontal lines. All lines are straight. Okay, this is at 1. This is at negative 1. H of 0 doesn't exist. Good enough. Do you have to say the limit doesn't exist? No. You can. Will that work? Absolutely. But I always try to do the easy things first. So on A, 0 and negative 4, they just don't exist, so I'm done. I wouldn't even go into the limit part because then you really have to do some work on that one. Because one's a vertical asymptote at -4, and you have a hole at 0. They are two different issues. But basically, the value of the function doesn't even exist at those points. Okay, is this one okay? By the way, the y is justifying your response. And here's the y. H of 0 does not exist. I always answer the y first, because then it tells me what to look for. And you'll hear me say that all year, because we're going to justify answers all year. We did B. Oh, yeah, D. Anybody know what function that is? Because I'm sorry, my... Yeah. And if you don't know on the test, you ask. If you are not understanding notation or you can't read what's there, you ask. Because I'm not evaluating you on that. I'm evaluating you knowing the math. Now, do you remember what happens when we do this? When you put a 2 on the inside. Yeah, it's a horizontal and it shrinks it. My gut feeling is to say, oh, it's going to be stretched twice as big. But that's not correct. This goes through the cycle if it were cyclic, but things happen twice as fast. So let's look at the picture of this. You do need to know what greatest integer function looks like. And let's do it in red. Okay, here's the regular greatest integer. There's a closed circle there, and open, closed, open, closed, open. And these are at 1, 2, 3. Where's the discontinuity on the greatest integer? And all the whole numbers. What about the negatives, too? What about -1? Yeah, so all the integers. That's why it's called the greatest integer function. They're all the whole numbers and their opposites. Okay, now let's graph 2x. Remember, it's going to be twice as fast. So it's going to jump more quickly. So it's going to jump here. Does that make sense? It's a horizontal shrink. And so then it's going to be up here, and then it's going to be here. Whoops, I'm not up far enough, etc. Okay, so where's the problem? Does the function exist everywhere? Yes, every single place it exists. But we have these jumps. What's the problem with the jump? It's supposed to be filled in there, sorry. The limits don't exist because the limit from the left does not equal the limit from the right. That's my justification. The limits do not exist at, because the limit from the left as x approaches c, I'll do c, from the left of j of x does not, well, it's fair what the c values are. So this is the justification. Yeah, we're going to get that in a second. C from the right. Okay. I like to justify them first, because then it tells me what to look for. Yeah, well, where is that? Let's make a list. Because if I make a list, then I bet I can do this. Does it jump at 0? Yeah, it does. So my c values are going to be 0. Where's the first jump? 1/2. Where's the next one? 1. And by the way, is the list sufficient? Yes. 1 and 1/2. 2. 2 and 1/2. What about all the negatives of these guys? Yeah. I should do plus or minus. Whatever. And they're opposites. Okay, and you could go dot, 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 and that would be okay. It's good enough. But could I be a little more succinct? Yeah. Where is it jumping? Every half, right? You could write multiples of 1/2. That works. Or some of you like to be a little more elegant, and you'll say n times 1/2, where that's an integer. I don't care. Do I get the point across no matter what? Yeah. Is that okay? So that's the problem. Limit doesn't exist there. I like to do the questions first, the reasons first. How about number 6? Did you graph that? Did you have a problem graphing it? Well, let's look at that. Let's not make this hard. You know what? I'm just going to use substitution. Okay? James, question? Did you get it? Yeah, go on, no problem. If you're I'm just going over this, but if you get stuck on something else, think about that, something else. First off, we have x squared, for x is less than negative 3. Well, I'm going to put in negative 3. And I'm going to have to recount these, otherwise I'm going to be off my graph. So it's 2, 4, 6, 8, 10. Not mine, not once I fix it. I'll be fine. On this, you're going to have to count by 2s if you want to get on the graph. Okay, so at negative 3, what's this function getting close to? What's negative 3 squared? 9. I don't get to include it, though. And we know what a parabola looks like. But, I could put in negative 4. So negative 4 squared is 16, so it's way up here. So it's going to look like this. Okay, girls, is that okay? Mm-hmm. And then what? No, then I got to change colors, right? Yeah. Let's do green. And this one is negative 3. Oh, I can. We'll do pink on the next one. How about that? X is between 3 and negative 3. Well, let's put in negative 3. This is getting close to. Negative 3 times negative 3 is 9. What about 0? We get 0. So it's going to be here. I'm going to leave it open, 0. And what about positive 3? It's negative 9. I just do a table of values. I mean, I could do slope, but this always works. And that's a hole here, and this should be a hole here. We're going to fix that in about 2 seconds. And which pink do you want? That one? I don't know if we'll see it. We'll see. Okay, what's the last one? 3 minus x. Oh. 3 minus x for x greater than or equal to 3. So I'm going to put in 3. What's 3 minus 3? 0. And I could do slope if I wanted to, or I can just substitute 4. Negative 1. It's a negative 1 slope. But sometimes we get mixed up with slopes, so that's why this always works. Pardon? Right. There's your picture. Just evaluate the function in these 3 places. Okay, so now we can answer the question. A, what's f of negative 3? It does not exist. Now, did I need a graph? I don't need a graph, but you guys, I think the graph helps. And then it says, what's the limit as x approaches negative 3? So I'll slide it. As x approaches negative 3 of f of x. Okay, so we are going to travel on this road from this direction and coming down there. What's it getting close to? 9. Yeah. Is this getting any easier?
Wait, so A is
Okay.
A does not exist, and then B 9, and then C does not exist.
Why does C not exist? That's correct. What's not equal?
We're not approaching
What's they?
the 2 lines.
Limit from the right does not equal the limit from the left.
Okay, the value of the function from the left does not equal the value of the function from the right. Can't use the word it, can't use the word they, because we'll mark it wrong. You have to be real particular. This guy makes me think of back when I was camping out in Wyoming with my in-laws, and they had a van and we had a van, and we switched kids along the way. Well, we got separated. So that night, I have the wrong kid, and we end up here, and they ended up there. So I didn't have my kid that night. We had no cell phone service. You're out in Wyoming. There's nothing there. So I had no idea where she was. Eventually, we got everything arranged. But
Did you know them?
yeah, they were my in-laws. But still, you always worry about your own child. That's just the way it is. So I had their kid, they had my kid, and this is where we spent the night. We were in one place in Wyoming, and they were there. Didn't meet up. So this does not exist. We've both finally ended up in a cell phone coverage area, but we had to do that because we had no idea where the other one was. It was kind of funny.
Were you like right next to each other?
No, we were about 150 miles away. Because we went down a road with an 18% grade with a motorhome. Oh, that's what it was with a motorhome, wasn't a van. And they went down the 18% grade. We turned around. That's because we used GPS to find this road that barely existed. So don't always trust your GPS. It'll put roads where they don't exist. I even ran into it this year. That was down in Red Wing. Swears it's there, but it's not there. So we had to go back 150 miles the other way because we couldn't get down that road. They went down the road. They said it was pretty scary. But 18% grade is pretty steep. Okay. It's making more sense? You guys deal with limits and stuff like this all the time. Last class said, well, where would we ever use calculus? And I said, well, how many of you have DVD players and iPads and things like that? All of you. All your electronics is with calculus. And imaginary numbers. One of my former students designed one of the chips that's in the iPhone. One of my former students from Minnetonka designed one of the chips in the iPhone as an engineer. So yes, he uses calculus all the time. Yep. We'll do the hard ones. E and F are hard, but okay. Oh, we did E? Oh. No, because I've done the problem several times. I know I'm not saying you didn't. Now, you can't memorize all of math. I have a book of CRC tables with a lot of math in it from the 70s, and it's thick. Nobody can do it. So you got to understand. This is going to be really important in the next chapter. Okay? That's going to be really important in the next chapter, so don't ignore it or not do it. It tells me what to do. I want to find this limit. I like to do easy things first, because then I feel better about myself. So I can find f of 2, can't I? What's f of 2? It's 2 over 2. You could leave it that way, you could change it to 1. So some of you may have left it 2 over 2, but that's fine. And now we'll do something a little harder. F of 2 plus h. So in place of x, you're going to put in the 2 plus h. Well, I did f of 2. So this is 1. It's a formula. It tells me what to do.
Why'd you put 2 on?
Because it said that's f of 2. Tells me what to do. So I want to find the value of the function at 2 plus h. I'll find out what that is and put that in there. Okay, what is f of 2 plus h? It's 2 over 2 plus h. Now we'll just follow. This is just my little thinking work. I don't usually write it down. I just actually do it. But that's okay. Write it down if you need to. It's the limit as h goes to 0. Now in place of f of 2 plus h, I'm going to put in f of 2 plus h, which is 2 over 2 plus h. I can't think of anything else to put in there, can you? I'm just replacing 2 plus h into this function right there, and then I'm going to take this whole thing, which is right here, and put it right in there for that. They're equal. It's like going to the restaurant and saying, I want french fries. I don't want a salad. Or some of you may do the other way around. I don't want a salad. I want french fries. Substitutions. Is that backwards? What's f of 2? What do we have? We have 1. All over h. Now 1 is really 1 over 1. That's one of those complex fractions again. How do we deal with complex fractions? Multiply numerator, denominator by the product, the multiplication of all the denominators, which I'll write them all out just so that you see they're all there. Some of you say, well, you don't have to do the ones, and I agree, I don't, but I'm just showing you I do have all 3 denominators there. Okay? Now, do we have problems with distributing with the algebra? I'm going to take this right here and distribute times this one, and then I'm going to take it times that one. It's just distributive property of multiplication over addition. Can we, do I need to write it, or can we just do it? Because what happens when I take this times this, what happens to the 2 plus h's? They cancel. I'm still left with a 2. Just a 2. Because I'm going to take 2 over 2 plus h times 2 plus h. I'm going to have to do both. This is the first term. This is, then I'm going to take 1 over 1 times 2 plus h, except it's a minus. So let's see. These will cancel, so I'm left with 2 minus, and nothing. I mean, the 1s cancel if you want to think of it that way, but what am I still left with? 2 plus h. Do I need parentheses? Yeah, but don't write this out, because you know what? If you don't write it out, you're not going to distribute your negative sign, and you're going to get it wrong. And how do I know that? Because I've been doing this since 1991. I've been teaching since 1976. I know, back in the Vietnam era. Yeah. Because I had to clear out my fractions because I'm left with this. I know, to you it's just a history book. To me it's real life. People who remember World War II, there aren't too many of those people around still. My neighbor was in a concentration camp. He never would talk about it in Germany.
Now he does.
No, he's probably passed away by now, but never would. And I had a friend that was in the Vietnam War. He was a photographer. He would not talk about the Vietnam War. It was too painful. Yeah. War is not a nice thing. Okay. Luckily, you haven't really, I mean, you have a little bit of it, but not like we did growing up. Okay. What are you going to do with that numerator? Can you cancel the 2 plus h's? No. This is a parentheses. An order of operations says I have to simplify all that before I can reduce. Well, it's not just order of operations. So it's 2 minus 2 minus h. So those of you can just go right to that step, great. But most likely you will miss the negative sign. I've taught it too many years. I know where the mistakes are.
Don't forget to get.
Now what's going to happen? Simplify. Because you can do this, right? What's 2 minus 2? 0. Whoopsie, I want that. So it's the limit as h goes to 0. Now I still have that negative. Don't be sloppy about that. It's still there. And it's h times 2 plus h. And this really is times 1. And now I can reduce. Because I'm going to divide by h. It goes in 1 time, not 0 times. And h goes into h once. So I'm going to be left with, the negative's still there. It's the limit as h goes to 0 of negative 1 over 2 plus h. So it's negative 1/2. Easy, easy to miss the negative sign. Because we always substitute in, right? This ugly looking thing, you can put this into your, it really isn't because it's because I'm teaching it. You could put this into your calculator and graph that thing. It really looks like this graph. Negative 1 over 2 plus x.
Can you do the back?
Mm-hmm. H is 0. 2 is not 0. Okay. Are we okay with the front side? Okay. By the way, 7b doesn't exist. There are jumps there. The limit from the left does not equal the limit from the right on 7b. I think the fraction on E is harder than the fraction on F. That would be good to get to the back because I didn't in my other class. If we still have time, we'll come back and look at that. Okay, James? I had my cell phone in 1994. I'm the queen of text messaging, you guys. Jeez. Okay. How about 4? How about A? 8A doesn't have an 8 there. Are you okay with that? Well, I do the easy things first. First off, the domain is fixed. So that makes it easy. Oh, let me grab my graph. Okay. Then it says that f of negative 3 is equal to 2. F of 1 is equal to 2. We should all be able to do this, right? and f of 3 is 2. And it says, I'm going to highlight this. Now, unfortunately, on the exam, you may not use colored pens, pencils, or highlighters. I don't know why. I think it's crazy, but that's okay. -1 and 1, I have discontinuity. I'm just going to color it. So I'm going to have a discontinuity there just to help me remember that. And it says the limit as we approach -1 from the right is what? Infinity? So as I approach this -1 from the right, it's going to do that.
Wait, how do you know that again?
It says so in D. And in E says x approaches -1 from the left. That's also infinity. I know it's continuous, not at -1, but I know this has to be continuous. That's one answer. Could it have done something like this? Sure. There's more than one answer. I'm just saying, just the fact that you have this continuous, that's it.
Well, isn't that not a function, though?
That's a function unless I make it vertical. I'm hoping it's not vertical. The limit as x approaches 1 from the right is 4. So it's going to go up here to 4. And it says this is 2. So could I do this? And this has to be continuous except at 1. So if I come down here and connect these two,
Wait, why is that black line so much?
it doesn't have to be there. I'll get rid of it. I'll try to get rid of it. It's just to show that there's more than one answer. Yeah. There it is. Same with this. This could have come all down and done the crazy things too. It doesn't matter. No, could you have done this? Could you have done this? Yep, you could have done that too. Okay, in the back?
Wait, did you have to use vertical asymptotes or no?
Yes, it's a vertical asymptote because the limit as x approaches from both sides is infinitely large.
It's infinite.
Yep.
Okay, how do you
Okay, number 9.
9A and B and C.
And then when we do this, we'll come back to anything that you need to see again or we didn't do. Is that okay? Now, where is the problem here? If you put in 0, what do you get? You get 0 over 0.
How do you know that?
Because what's the now, how do I remember the tangent of 0? Because I know the tangent looks like this. Uh-oh, they're going to mess me up back there.
Guys,
There's the tangent of 0. Okay? What is tangent? Noah, what's tangent? Sine over cosine. Over t. Now, the only problems I ever have are with zeros, right? I can't divide by 0. I can't have 0 over 0. That's the only problems I ever have. I can divide into 0. So go ahead, because by the main limit term says you can do this. Go ahead and evaluate those things that are not 0. That's not 0. What is the cosine of 0? Perfect. So this is actually equal to this. I mean, you could do the complex fractions, but let's just evaluate and keep it simple. Because that's 1. I mean, if it were 2, you'd pull the 2 out. And then you'd have to worry about where it goes. But it's not. It's 1. So it's 1. Yeah.
wait, sine of t over t.
Do you remember that the limit as x goes to 0 of the sine of x over x is equal to 1?
I times each one my cosine.
You can simplify it, and then you pull it out, and you eventually evaluate it. Let's just evaluate it now. I evaluate everything that's not 0. Just get rid of it. It just will be a constant of some sort. The only place where there's trouble is at 0. So I can't just evaluate sine of t over t. But I have a theorem that says I can do that. I know it's 1. So what about this one? Now, on your graphing calculators, here's another issue. You cannot type in sine squared of t. You can try it, but the calculator doesn't know how to do that. It's the sine of t quantity squared. So what I'm going to do is write it out differently. When I don't know what to do, I'm going to try to change how it looks. So it looks like this. Right? Okay, girls?
Could you change the T's to X's?
Sure. These are dummy variables. As long as I change them all, I'm okay. So I'm going to rewrite it this way. Are those the same things? Properties of fractions. Are they the same?
Yeah.
Whoops, yeah, no, they are, aren't they? Multiply it out. If I have A over B times C over D, that's the same as A times C over B times D. So it goes both ways. That's the same thing. Okay, change the T's to X's. That was the request, but it doesn't matter. They're dummy variables. So I really could, I mean, I can go right to the answer, but I really could have written it, now I could write it this way, because limits do distribute. They do, which is kind of cool. Because what's this one going to be? 1. What's this one going to give me? Yeah, what's the sign of 0? Yeah. So it's 0. If I don't know what to do, I'll do what it tells me to do. I'll write it out. Except the next one is a little trickier. Some of you try to pull out that 3. You cannot do that. Is the sign of 3x equal to 3 times the sign of x? We could go to our graphing calculator, but this has an amplitude of 3. That has an amplitude of 1. This just cycles through 3 times faster, that's all. It's just a horizontal stretch. It is not a vertical stretch. So guess what? You can't do that, and if you go right to the answer, I'm going to mark it wrong because you have to convince me that you know what you're doing. And if you just pull the 3 out, I don't believe you. You could have written it off, gotten off somebody else's paper, off the internet, who knows? I want to see the work. So this theorem that we have up here, which is right here, it's true if this is 3x and 3x and 3x, it doesn't matter what it is as long as they all match. So we're going to make that match. So to make this match, I have to multiply by 3. Right? And what do I have to do then? Multiply the numerator by 3. Now, if x goes to 0, doesn't 3x go to 0? Yes, I mean, if I want to be technical about it, I really should put a 3 here. I won't be picky about that. Uh-oh. My plan might have fallen apart here. What can I do with this 3? I didn't want to connect them. Okay, I'm going to put it out in front. I goofed on that. That's true. There we go. And now, as long as these match, and they really, you could put a 3 there. You don't have to, but you really should, I suppose. But you don't have to. I'm not going to make you do that. And then you get, now what can I do with this 3? I can pull it out in front. Except I want it in the numerator. There it goes. So now I get 3 times the limit as 3x goes to 0 or x goes to 0. I mean, you could do a substitution. These just have to match, that's all. I'm going to color them. This has to match with this, and if x goes to 0, you better make sure that that will also go to 0. Whoops. So what's the answer? If you don't show me this in-between stuff, I'm going to mark it wrong. Because I'm going to assume that you pulled the 5 or the 3 through. You just have to make these angles match. Because the theorem is the limit as star goes to 0 of the sign of star over star. Or hearts. I don't care.
So we do have to show the 3x?
This little 3 here, no. Because I haven't really taught it that much. But honestly, that's the correct way to do it. Okay, is it time to go? Oh, it is almost.
Oh my god.
Well, we have time for one more. Does. 7C, we've done it before, but we're going to do it again.
You can never do it too much.
Remember, these are tricks. Yep. Okay. Some people want to factor it. You can factor that, by the way, but I think that's harder. That's one trick. Another trick is to say, I want to change how this looks. What could I multiply the 2 minus square root of x?
Plus.
Yeah.
Um,
Now, if you understand fractions, you can see I haven't done this right because I have to multiply the denominator by the same thing. And now, a lot of you want to distribute that in the denominator, but I can't cancel then. It has to be all multiplication. So we will multiply out the numerator because that's how I chose it. Do you have problems with foiling? 7c. 2 times 2 is 4. Minus 2 square root of x plus 2 square root of x ends up with how many? 0. And a minus square root of x times a positive square root of x is, and it's really times 1. And there you go. Kind of obvious now, isn't it? What happens? See, I don't know what to do, so I'm going to change the form. Sometimes you have to just try thinking outside the box. That's a 1. So I get the limit as x approaches 4 of 1 over 2 plus the square root of x. Now substitute it in. It's 1 over 2 plus 2. You see why it's not 4, but it's 1/4? Because when I do that canceling, I'm dividing by 4 minus x. It's important to realize that. Okay, I am here. I'm going to be in this room after school tonight because we have math team introduction, but you can come if you want to come and learn about math team and ask me questions. And then in the morning, I'm in 1410. You have Hersman in 1400, me in 1410, and Dahmen in 1410. Should find somebody. But he's pretty busy with the pre-calc people all the time, I've noticed. And it is time to go.